Hello, welcome. Let's try to solve another Leetcode problem. 1986, a minimum number of work sessions to finish the tasks. So for this problem, we are giving n tasks, and we are also giving a session time. So all the values inside of the tasks are gonna be less than or equal to the session time. So for example, session time is 3, and each of the tasks is 1, 2, 3. It's gonna be less than or equal to this is 3. And we're gonna return the minimum sessions we're gonna finish all those tasks. Yeah. So for the first session, as the session time is 3, so we can finish the first two tasks. So it's gonna be 1 plus 2. So this is gonna be the first work session. And for the second work session, we're gonna choose another 3. So it means yeah, the minimum is gonna be 2 sessions. We can finish all the work. And for this example, the session time is 8. We can choose 3, 1, 3, 1. It's going to be the first session. For the second session, we're going to choose only 1. Yeah. So this problem can also translate it to we are giving an array of tasks. Yeah. So we are giving an array of tasks, and yeah, this can also translate it. We are giving an array of numbers, and the total sum of the numbers maximum can be 3. And what gonna be the minimum groups? We can split the numbers array. So for example, for this example, we can split it into two arrays, 1, 2, and 3. So it's gonna be the minimum. But 1, 2, 3, there's no sequence for this 1, 2, 3. Yeah. Now let's just check what we are giving. So the length of the tasks array is 14, and the task I is 10. Yeah, and the session time is less than or equal to 15. So this means we can solve this problem by using bit masks. Because for bit masks, 2 to the power of 14 times the session time times 15 is going to be a really small number. How can we use the bit masks? So for example, if we are giving the array like 1, 2, 3, this is going to be the tasks. Now, what we can do, yeah, we just need to finish all those, enumerate all those tasks. Yeah, so we can use bit masks to represent all those numbers. So for example, from the beginning, we're going to prepare a bit mask. It's going to be our initial state. It's going to be 0, 0. So if we take any two numbers, for example, if we take 1 and 2, it's going to become 1, 1, 0. Yeah. So if this is one of the session time, we're going to record it as 1. Now we're going to just find another one, 3. So it's going to be 1, 1, 1. So this is going to be the bit masks. Yeah. So if we can find this 1, 1, 1, basically it means we finished our task. Yeah, because basically we need to finish all those ones. Yeah. So if we finish those tasks, it means we're gonna return a 1, because the last one, yeah, we're gonna need another session for the last one. Yeah, so basically we just need to use the bit mask to check. If we choose the first 2 as 1, so it's gonna be 1 plus 2, so it's gonna be 3. So this 3 is less than and equal to the session time. Yeah, so this means we cannot choose another one because it's going to be more than 3. So currently we're going to have a record. So this is going to be 1 session. And then we're going to finish the last one. For this 3, it is okay. And we finish all the state is going to be 1, 1, 1. So this means we finish the last one. It's going to be a 1 plus 1. So it's going to be 2 sessions. Yeah. Now let's just use this idea to solve the problem. So we're going to prepare the length of the tasks. It's going to be n, and we're going to prepare a test, and we're going to define a function f. So instead we're going to prepare the state and the time. So finally we're going to call the function. So state is going to be starting from 0, and the time is going to be the session time. Yeah. So now the condition is that if state equal to 2 to the power of n minus 1, yeah, it means we finished choosing all the tasks. So we're gonna return 1. Yeah. Now we're gonna enumerate all the possible tasks. So for I in range we're gonna have a check if this is state and one shift left to I base. Yeah. So if this is a 0, it means currently for this number, maybe this 1, 2, or 3, this number is not taken. Now it means we're gonna take this number. Yeah. Now this means we're gonna take this number and we're gonna update the state. But before that, we need to check the time. So if our current time is less than the current tasks for this task, it's going to be tasks I. Yeah. For this current tasks, so for example, this is a 3, but our current time maybe our current time is only 1. Definitely this, if this is 1 and this is a 3, definitely I cannot finish this tasks. So this means I will use a new session. So the session going to be set to 3 instead of 1 here. Yeah. So I'm gonna update the result. So the result from the beginning I'm gonna set as infinity. So here the result gonna be updated to minimum, because yeah, we're gonna choose the minimum time. So it's gonna be the f function, and we're gonna update the state. Here we're gonna use all, and 1 shifted left to I base, shifted left. Yeah, so for this bit, we're gonna shift left to I base, and we're gonna set it as 1 bit instead of 0 bit. Yeah, so this is for the state. And what about the time? Because we are choosing a new session, so basically it's gonna be the session time. Session time minus the tasks I for this tasks. Yeah. So let me just cut it from here. And yeah, here is just inside the function. Yeah, so for this f function, basically I need 2 plus 1. This means I'm gonna have another new session. This means I've already finished 1 and 2, and this is a new session. So currently, yeah, the minimum value gonna be 1. Yeah. Now I'm gonna try to find another one. So this means it's gonna be another case. So else, if my current time, for example, if my current time is new session, for example, if it is 3, so it's going to be bigger than and equal to my last tasks. So for bigger than and equal to this is 3. So this means yeah, this is another choice. So this is another choice. I'm gonna choose the minimum of the result with f state with all 1 shifted left with I base, and here it's gonna be my time, because my time is more than equal to the tasks I. Yeah. But I don't need to plus a 1 because I didn't use a new session. It is my current session. Yeah. Now all those functions gonna go to the recursive function will go to this f function. Yeah. So if this state is 1, I mean the state is 1 1 1, all the bit is 1. This means I'm gonna check this state. So this means for the last time. This means for the first of all, I finished all the tasks. Yeah. If I finished all the tasks, this means I finished all the tasks successfully. I need to return a 1. This one gonna be the last one to finish. Yeah. Now let me just run it. Yeah, let me just run it to check. Yeah, here's something wrong. None add float. Oh, I did something wrong. Let me check. So this is my function. This is f. Yeah, let me just copy this one. Maybe something wrong with it. So here I don't need 2 plus 1. Here I need to use the time minus the tasks I. Yeah, now let me just run it. Yeah, I think I needed to, yeah, I forget to give a return. That is why there's going to be a non-type, because I didn't return the result. Basically, this is a dynamic programming. Yeah, now as you can see, it works. Now let me submit it to check if it can pass for all testing cases. Yeah, now as you can see, it passed for all testing cases, and I think the speed is okay. It is 5 minutes because we use the bit masks. So for the time complexity, it's gonna be this state 2 to the power of n. So this n gonna be 14. Yeah, 2 to the power of 14 times times the time. So the session time gonna be 15. So 15 times 2 to the power of 14. Yeah, and inside there's gonna be another n gonna be 14. So 15 times 14 times 2 to the power of 14. Yeah, so basically this is like 15 like 2 to the power of 4, this 14 like 2 to the power of 4, so 2 to the power of 8, and 2 to the power of 14, so the time complexity is going to be 2 to the power of 22. That is why it works. Yeah, I think that's all about this problem. Thank you for watching. See you next time.